Hey, Jody here with weldingtipsandtricks.com. In this week's video, we're going to be doing some more scratch start TIG welding, but also some stick welding using 7018 rod. 1/8 diameter, that's 3.2 millimeter, 7018 rod. And I'm going to be using a Miller Thunderbolt for some of the scratch start TIG, but then I'm going to switch gears and pull in a tiny little inverter power source. Let's do it. In last week's video, I did some scratch start TIG welding and showed the setup with this Miller Thunderbolt XL AC/DC transformer machine. And one of the quickest and easiest ways to do that is just get this TIG adapter block, part number 105Z57, clamp your stinger, your electrode holder directly to that. The only problem is now all that stuff is live. So you get up against it, you got a little problem. So I had a comment on YouTube from Ryan Jones, and he says it's a good idea to use something to protect that adapter block you connect your stinger to. I use an empty quart-size oil jug that I cut the bottom out of, but you can use any bottle that's big enough. So a big thanks to Ryan Jones for leaving that comment, and we'll go over that in just a second. Now, this is a carbon arc gouging rig. It uses the same concept, and I thought that I would just recommend people buy this rubber boot, but they're pretty hard to find. So we're going to go over using a water bottle to protect this little energized adapter block. I'm going to just kind of eyeball this water bottle, and so glad I found my little Milwaukee knife here. That thing's been missing for a while. I love that little thing. And we'll cut the bottom out of that and see how we fare. Just going to feed, this is the argon hose coming from the flow meter. I'm feeding it through there, and I'll hook up the power block to it and attach the stinger, and we'll see how see if I cut it the right length here. And it looks like it's just about right. Now what I would probably do is put a little electrical tape over the small neck there, the threaded in there, and just leave that there set up. And it's just about the right size. You can easily get the stinger in and out, so you don't have to keep removing the bottle. All right, let's do a little quick review of last video. I used the Miller Thunderbolt, and I was set at 104 amps. I checked that with an ammeter, and I ran an open butt root pass in a plate here with a 1/8 gap. That's a 3.2 millimeter gap. I left the sound of this transformer machine just so you can see how loud it buzzes. Miller Thunderbolt's got quite a loud buzz to the arc and to the machine, but, well, it's pretty good. So I did a part of a root pass freehanding and then part of it walking the cup. And if you're going to walk the cup, you need to really wiggle tight. Don't do much side-to-side motion. That way you get some push-through on the root pass. Now it's time to put the hot pass in. Welders call it the hot pass, but it's not always hotter than the root pass with TIG welding. You got to remember, one of the main goals of the second pass or hot pass is not to screw up the good root pass you just put in. So if you push the nice root pass through there, the last thing you want to do is suck it back. I'm going to flick the rod here to start the arc for the second pass, also called the hot pass. And I'm set at roughly 120 amps, still using that Miller Thunderbolt. And I've got that sound kind of muted because it's just really annoying. It's got a heck of a hum to it. Basically, I'm moving pretty quickly across the center. I don't want to heat that root pass up, so I'm just bouncing kind of from side to side fairly quickly. I'm using a 1/8 rod and putting a little pressure on it in case it wants to accept a little rod. I'll satisfy the puddle, keep it cooled off. All right, I'm going to shift gears here now and get off the Miller Thunderbolt, and I'm going to use this tiny little inverter that weighs about 20 pounds or so, and not much bigger than a welding helmet. But it's a 160 amp machine, so it'll handle what I'm doing right here. I'm set roughly 115 to 120 amps right here. Doing a little cup walking, which is a good way to put a hot pass in if nothing's in your way. You can also use more amperage sometimes. It just depends on the situation. Like if you're in a fab shop and you're rolling a joint out, you can definitely go hotter and faster, but you do have to be careful. One little slip up and you can screw up a root pass. All right, I'm going to crank it up now to 149, 150-ish. What I'm going to do here is because it's plate, if I'm going to walk the cup, it's hard to start on the end. There's no place for the cup to rest or walk. So I'm going to start off just kind of freehanding it, and then gradually as I come inboard, I'm going to tilt the torch back a little bit more, lean it back until finally I have a place to rest the cup. And I'm far enough in and got it leaned back far enough, and then I can start walking the cup. Normally you wouldn't walk the cup on plate. I'm just messing around here. Walking the cup is primarily, really comes into play on pipe. That's where it really shines. And I have to apologize for the piece shaking around here a little bit. The stand that I have it on is a little bit wobbly. I should have fixed that for the video, but had to drive on. Got deadlines, And you can see it wobbling there. I should have used a more rigid stand, but maybe next time. All right, we're going to go to stick welding now. 1/8, 3.2 millimeter, 7018, and all I've got to do is swap these leads so that I've got electrode positive, and then come up here and push the button, change from TIG to MMA. Now, we don't talk about MMA much here in the States, but it stands for manual metal arc welding. It's stick welding, what we call stick welding. So this is a 7018 run at 120 amps. DC electrode positive, and I'm just trying to leave a little bit of line there at the bottom so I can have a straight line to go by for the cover pass. Now, I showed this lighted chip and hammer in a previous video. I still don't think it's available just yet. It is listed at wertech.com, but I don't think they have them yet. I'll keep you posted when they're available. Now, I have said this many times, but I'm going to say it again here. It's really good advice for anybody learning to stick weld or any welding student. Almost for any occasion, set the machine hot enough that the rod won't stick when you hold a tight arc, then hold a tight arc. Alright, so we're ready for the cover pass now. I have previous videos showing a 2G weld like this, start to finish, that's got a 22.5 degree bevel on it like you would take for a structural welding test. Right now, I'm really just trying to test out the welding machine, burn a bunch of rods back to back without giving it a whole lot of time to rest, and see how it does. And it's doing okay, no problems. Now, this was intended to be the very last pass. I was going to do a 3-bead cover pass, but I wound up having to run a really quick one just due to some slight undercut, and that happens sometimes. I don't want to say that Miller Thunderbolt is an inferior welder. This is some stick welding done in a previous video, going uphill 90 amps with a 3/32 7018. It's a good little stick welder. Let's get back to some scratch start TIG now on something that is really common. Just square tubing joints. Just a 90-degree joint on a square tubing, the end to the flat side. And we'll talk about a little bit here about stopping. Now, what could you do with a scratch start TIG? Why would somebody at home even care about that? Well, you could build a lot of stuff. I mean, a lot of the welding, not a lot. Any of the welding carts that I have built, you could build them all using scratch start. And if you didn't have a MIG welder and all you had was a stick welder, scratch start TIG would probably be a little bit better choice on some, thin wall square tubing than maybe stick welding would. Maybe, maybe not. Just depends on what you want to accomplish. But here I use the copper spoon again to come out of the puddle. And you could use a copper spoon, you could use pieces of aluminum, block of aluminum. Here I'm going to show coming out of the puddle on that block of aluminum on this type of a joint. And when I get to the very end, it's just a matter of pulling the arc over onto the copper spoon or the block of aluminum. So here I'm going to add a little dab of rod and come over to the block of aluminum, then snap out. Now, I would definitely prefer a foot pedal on something like this, but just trying to show you what you can do with a simple scratch start TIG. It's pretty nuts that today you can do scratch start TIG with a welder that weighs like 20 pounds. All right, well, that about wraps it up. As always, I appreciate your time and I appreciate you spending time on my channel. See you next time.